Radian mental math. All right. You might think that this section isn't super necessary because maybe there's not a homework problem that has you doing Radian mental math, and that is true. But let me tell you, if you learn a little bit of Radian mental math right now, you can really make so many things easier for yourself. Um, you can avoid pulling out a calculator to do obnoxious math, and you can figure something out like where would 17 pi over 12 be? Right? Here's like a unit circle. Where is 17 pi over 12? What quadrant does that lie in? How can you figure that out? So we're going to talk about it. Um, the easiest way to figure out where something like 17 pi over 12 would be on the unit circle is to relabel all of the axes by using the denominator of the radian measurement you're looking at. So typically the way that our little like quadrant system works here, right? It's like this is 0 for radians, this is pi over 2, pi, 3 pi over 2, and then this is also 2 pi, 0/2 pi. So this is how we typically label it, but that's not very useful in terms of 17 pi over 12. Where does that belong on here? So we just rewrite these fractions so that they have a denominator of 12. And uh, then we're good to go. So the process looks like this. You take the denominator and you cut it in half. And we're going to reform pi over 2, but with a denominator of 12. So cutting the denominator in half for 12 is 6. So up here, it should be half the denominator, 6, over the denominator, 12. If this simplified, it simplifies to pi over 2, right? You would cancel out the 6 goes into it. 6 goes into itself once, 6 goes into 12 two times. So that's really just 1 pi over 2, pi over 2. I am just rewriting the fractions. And then it's so easy, guys. You just keep adding whatever that number is, that half number, you just keep adding it to the numerator until you've gone all the way around the circle. So 6, we're adding 6 pi technically, but I just think of it as adding 6. So starting with 0 pi over 12, adding 6, 6 pi over 12, add 6 to the numerator, 12 pi over 12. So it goes from 6, 12, 18, 24. And looking here, 24 over pi over 12, 24 has 12 go into it twice, 12 goes into itself once. This is 2 pi over 1, which is just 2 pi, which is exactly what it should be. And it makes it real easy here for us to tell where 17 pi over 12 is. We just look at these numerators, right? Let me erase this work over here. So 17 pi over 12 is between, 17 is between 12 and 18. And so I know it should be in this quadrant 3, and probably closer to the 18 pi than to the 12 pi. And that would be, boom, right? 17 pi over 12. So we'll do a couple examples of just rewriting our spokes, our spokes of our coordinate system. Oop. Okay, just freezing a little bit. There we go. All right, we're gonna rewrite the spokes with different denominators. So half, we're gonna do this, we're gonna do denominators of 9. Half of 9 is 4.5. And we are going to use 4.5 in the numerator, 4.5. We'll have decimals in our numerator and it will work out fine. No need to worry. So for all of the spokes, it's going to be something pi over 9. It's going to be something pi over 9. Something pi over 9. I can just fill these in right away. Something pi over 9. Something pi over 9. All right. We start with 0, 0 pi over 9, and then add 4.5 to the numerator. 0 plus 4.5, that's 4.5 pi over 9. Add 4.5. 4.5 plus 4.5 is 9. 9 pi over 9. Add 4.5 again. That's 13.5 pi over 9. Add it again, plus 4.5. Now you're at 18 pi over 9. And here's the cool thing we can do now. So if I was like, hey, friend, where is 11 pi over 9? What quadrant? Draw it. 11 pi over 9, we know it's going to be somewhere in here because it's 11 is between 9 and 13 and a half. Now would be a great time to pause if you want to try doing this denominator of 24. My iPad's being weird. If you want to try doing this one before I do it, give the video a pause. You've had your chance. I'm going over the answer now. All right, so half of 24 is 12. So I'm going to do this smarter than I just did it before. Let's see. And I'm going to boop. Duplicate, 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 and duplicate one more time. There it goes. All right, so we start with 0. Oh man, I just did that over 12. You're probably standing there like, Professor Cook, don't, no, you're doing it wrong. You know what's funny? I did that when I was putting my notes together too, twice. 12 and 24 really get me, probably because the example before had 12 in the denominator. All right, we're starting with 0, we're adding 12. The denominator is not 12, we're adding 12. You might think to yourself, Professor Cook, why not just restart the video? Because this is not a professionally produced YouTube video. I'm not a professional YouTuber. I'm not restarting this video. It's too long already. I'm not redoing it. This is the experience you asked for. All right, so 0 plus 12, that's 12 pi over 12. Or 12 pi over 24, my goodness. Adding 12 one more time. 12 plus 12 is 24, so we have 24 pi over 24. Add 12 one more time. You get 36 pi over 24, and you do it one final time, and you get 48 pi over 24, which is fun because then I can be like, oh, well, then where is 37 pi over 24? Where does that belong? What quadrant? And we could say, oh, it belongs right here in quadrant 4, probably just like a little bit past. And that would be 37 pi over 24. All right, so this mental math will come in useful, I promise. Thanks for sticking in here with me, and I'll see you in the next video. Bye.